Hello! Last time, we defined what it means for two games to be equivalent. In this lecture, we will look at a few more results about equivalent games that we will use later. The first result is the copycat principle. For any game G, G plus G is equivalent to star 0, which means that G plus G is a losing game. We have seen something like this earlier, where a NIM game with two equal piles is a losing game. Whatever the first player does, the second player will copy the same move on the other pile. And this can be generalized to any impartial game. And here is our proof. We prove by induction on the simplicity of G. When G has no options, G plus G also has no options. So G plus G is a losing game, which means that G plus G is equivalent to star 0. Now suppose G does have some options. With a loss of generality, suppose that player 1 moves from G plus G to G prime plus G. Then player 2 can respond by moving to G prime plus G prime. Since G prime is simpler than G, by induction, G prime plus G prime is equivalent to star 0. So it is a losing game for player 1. Therefore, G plus G is a losing game, and G plus G is equivalent to star 0. And that is the proof. As an aside, if we treat our games as equivalence classes, the copycat principle gives us the inverse of a game, which is itself. With equivalence relations, you can replace an object with an equivalent object and it should remain equivalent. So here, from G plus G is equivalent to star 0, we can replace G with anything equivalent to G and it will still be a losing game. So here is our lemma. G is equivalent to H if and only if G plus H is equivalent to star 0. See if you can prove this on your own first, and we will go through the proof soon. In the forward direction, from G is equivalent to H, we'd add H to both sides to get G plus H is equivalent to H plus H, which is equivalent to star 0 by the copycat principle. For the reverse direction, from G plus H is equivalent to star 0, we again add H to both sides to get G plus H is equivalent to star 0 plus H, which is equivalent to H. But G plus H is equivalent to G plus star 0, which is equivalent to G, by the copycat principle. So, G is equivalent to H, and that completes our proof. We illustrate this lemma with an example. We can easily prove that star 1 plus star 2 plus star 3 is a losing game. So star 1 plus star 2 plus star 3 is equivalent to star 0. By our lemma then, star 1 plus star 2 is equivalent to star 3. Now this looks like it's just 1 plus 2 is equal to 3, but that's not always what happens. We can apply the lemma again and get star 1 plus star 3 is equivalent to star 2. Now one consequence of the lemma is we can find another way to prove that two games are equivalent. We can do that by showing that the two games have equivalent options. And here is our next result. If the options of G are equivalent to options of H, then G is equivalent to H. More precisely, options being equivalent means that there is a bijection between options of G and H where paired options are equivalent. Here is an example. We can show that star 1 plus star 2 is equivalent to star 3 using this lemma. We see that star 1 plus star 2 has 3 options: star 2, star 1, and star 1 plus star 1. Star 3 also has 3 options: star 2, star 1, and star 0. And we can pair up the options from either side, noting that star 0 is equivalent to star 1 plus star 1. Since the two games have equivalent options, our lemma tells us that the two games are equivalent. Note that the converse is false, and you can easily find a counterexample to the converse. So here is our proof of the lemma. We want to show that G is equivalent to H, so by our previous lemma, it suffices to show that G plus H is equivalent to star 0. That is, G plus H is a losing game. This is certainly true when G and H both have no options. Now we suppose that G and H do have options, and suppose without loss of generality, player 1 moves to G prime plus H. What would be the correct move for player 2 in this case? Well, by assumption, there exists an option of H, say H prime, such that H prime is equivalent to G prime. So player 2 would then move to G prime plus H prime. And since G prime is equivalent to H prime, G prime plus H prime is equivalent to star 0 by our previous lemma. So G prime plus H prime is a losing game for player 1. So G plus H is also a losing game, and that completes our proof. So these are the results we need from game equivalences. In the next lecture, we will start to prove that all the NIM games are equivalent to a NIM game with just one pile of chips.